Welcome back for my channel. In the previous videos, I worked with this standard distance tool, which is part of this measuring geographic distribution. This time, we will work with calculating standard deviational ellipse using this directional distribution tool. So what is the fundamental difference? So if in the with the standard distance tool we computed this compactness, we saw the compactness, we can see the compactness of the spatial distribution. But this is not the only case why the distribution might be interesting. For instance, another interesting concept is directional trend. So standard deviation, which is calculated separately for x and y axes, will result in elongated circle or ellipse. If in a previous standard distance tool we can compute this circle which is equally measures for x and y, here for this compactness will be measured differently, separate for x and y. So by calculating variance for both x and y axes independently, we can show the directional trend. So result will be shown in ellipse, which orients the axes to match the orientation of the feature. So for instance, the orientation of ellipse may reveal a trend along a road stream. As with the standard distance, we can calculate the standard deviational ellipse in two ways. One is we can use either the location of the features as a built-in geographic fate, or the second one allows the attribute value to influence the location. So the latter method is the weighted standard deviational ellipse. So imagine the same area battalion. We want to calculate the ellipse for calls. Also, we want to calculate not just the compactness of the distribution along the active fire stations, but also the directional trend the calls came from. From the result, we will be able to visualize and any directional influence that the roads may have on the data. So once again, this is the calls for services for this region for February 5. This is active fire stations for each alarm territory, and also major roads. So roads will be important for us in this analysis because it will directly impact to the direction, to the shape of the ellipse, because fire engines use roads to get to the location. So it will impact both to the compactness and directional trend of the calls. So let's search for the tool directional distribution. So this is again in statistics tool, standard deviation. Let's open it. Let's take a fast glance. Create standard deviational ellipses to summarize the spatial characteristics of the geographic features: central tendency, dispersion, and the directional trend. So it incorporates within itself these three aspects of a geographic distribution, which gives us more comprehensive analysis comparing to the standard distance tool. So call for services, I use output is directional distribution, and directional distribution 1, let's say. Standard deviation case field is a station. So ellipse size is 10 standard deviation. The size of output ellipses in standard deviation. The default ellipse size is 1. Valid choices are 1, 2, or 3. So default, we will choose the default standard deviation. Okay, let's click OK. Okay. See that now we have not circles as we had for standard distance, but ellipses, because if we click on this calls, see that it shows the direction of trend as well. So it doesn't show only the compactness, the geography, not the central term, the density and dispersion, but also directional trends. So we can, for instance, zoom and see whether it matches with the roads. So see that these are along the roads, the directional trend. This is the main road. See, so that's ellipse is ellipse shapes from the ellipse is more prolongated for x-axis rather than to y. This is the opposite. It's much more prolongated for y-axis rather than to x. So if the distribution is not it's more equal for x and y axes, it will be more closer to the circle, like this fire station 2 and to some degree fire station 14. But if it's not proportional, it will have this kind of distribution. So it shows also the direction of trend. We can repeat the same tool, use the same tool, but this time we will use it with weight. So again, call for services, output directional distribution 2. Let's click OK. Standard deviation. Now we will include the weight field. So weight field, I repeat, if you just didn't watch the previous videos, it shows the importance of a call. For instance, the highest weight will be given to the calls which might cause the fire, which might be dangerous for human health or life, sometimes life and death situations. The second priority calls will be given to the fire calls which might be related to the real property damage, not the life and death situation for human life. And the least priority calls will be given to this sometimes false alarms or false calls. And we again include this station. So let's click OK and compare. So first we will need to change this outline color to yellow. So let's compare the weights. So see that when we included the weights, the result is slightly different, but the ellipse themselves didn't change the shape. I mean the direction. The directional trend is almost the same. So this 5 station, it's prolongated. The ellipse goes from south to north. Here's the opposite, from east to west. It's more vertical, it's more horizontal, but in some cases it changed the size. For instance, this here is the distribution is smaller when we included weight comparing to the cost when we didn't include the weight importance. So this analysis is for only 1 month's worth of data, and if someone will want to look at the change in the ellipse over a longer period, it might help to determine the most optimal placement of the stations based on the call. For instance, we can analyze the whole year calls for the certain region and use this directional distribution, including weight as well, to see where it is better to place the active stations. So let's click on this proposed station. So see that there is active station here and the proposed station. It's more close to the center, but it was computed using the standard distance tool. But when we compute, if we include this directional distribution, when the x and y are computed differently, we see that proposed station might not be the correct place to put the station. For instance, it might be better to put it here. The same thing is here, so it might be much better to put it here, etc. So see that when this kind of analysis might be helpful if your area is large and there are many residential areas and few fire stations for the region, and you want to maximize the efficiency of fire brigades and fire combating fire for the region to satisfy the needs of the citizens. It is best to use this directional distribution, including all the calls, including the weights, and put it to the center, for instance, of an ellipse. So it will take into account the spatial distribution, central tendency, directional trend, and the weight of the calls. So the highest priority will be given to saving human life, and the later and afterwards following with protecting the physical property. So in this case, such kind of analysis might be helpful, especially if the area is large and the fire stations might be small, or few, or for instance police stations as well. So in addition to showing data compactness like the standard distance circle, the ellipse can show a directional trend. The weights for the fire response data tended to draw the ellipse towards the freeway, so where many traffic accidents may have a large effect. So if the ellipses remain more circular, it indicates that the data does not have a directional trend. So what kind of other world examples? Police department might look at the standard deviation ellipse to spot the directional trends in crime, such as following a hiking trail or freeway. So or animal tracking data may be mapped with a standard deviational ellipse to see the direction in migration and grazing, and many other real world examples.